Okay, pathways. You're asked how many pathways from point A to point B. It is a permutation question dealing with identicals. This has to do with what we've already covered, identicals. Movements to the side, east or west, okay? East or west are considered identicals. I'm going to use a color that I'm going to keep using later on. Going east-west are considered identical. Moving up or down, north-south, are considered identical. Okay, so there are two methods you can solve a pathways questions with. The first one is a formula. So method one formula, number of pathways. Here you have it. And it is total blocks traveled. You see the factorial, right? Don't miss the factorial. Total blocks traveled, factorial, divided by horizontal. I'm going to use green because I used green for my side-to-side movement. And number of vertical blocks. Okay. So you're going to divide that out. And notice this little star here, okay, the star. This formula may need to be used multiple times if there are several stops along the way. I feel like you're going to miss it. It's so close to the box. Highlight that as well. Method two is counting. See examples, okay? Let's start with a nice and easy one here. Case one, only one direct route. It says, how many ways can you get from A to B, assuming we can travel north to south and west to east or east to west? So we can only go up and down, or we can go sideways. Okay, use both methods. And this is the method that I'm going to show you here. Counting, you do it right on the diagram, okay? So watch this. You start here, you want to get to B, correct? You ask yourself, how many ways can I get to this intersection here? There's only one way. If I travel sideways or up and down, there's only one way to get to this intersection. Guess what? There's only one way to get to this intersection as well. Like you only travel east, right? There's still only one way to get to this intersection. So you carry, in this case, the one. You start with ones all along. Same going south. There's only one way to get to this intersection, and there's only one way to get to this intersection here. Do you agree with me, or are you just copying? If you're only allowed to travel south, there's only one way to get to here, there's only one way to get to there. Now, how about this intersection here? How many ways are there to get here? You can go this way, one, or this way, that's two, right? So watch how I do it with the counting method. 36. Yeah. 36. 1 and 1, watch this. You add this number with that number, you put it down, it's 2. Then you add 2 and 1, you put that number, it's 3. 3 and 1, it's 4 to get to there's 4 ways to get to this intersection right here. I'm not going to tell you all the different ways, but you just have to trust me right now, there's 4 to get to here. You know something is wrong if people say you just have to trust me, right? It's like, don't trust that person. 3, right? 1 and 2 is 3. 3 and 3 would be 6 ways to get to this one. 6 and 4, 10. So there are 10 possibilities to go from A to B in this circumstance. Okay, so formula. Using the formula, okay, I'm going to go pathways. I kind of lied to you that I'm going to use 3 colors, not just 2. It doesn't matter if you're going to go this way and then down, or if you're going to go down and then over sideways, but you just count the total number of steps you're going to take. 1, 2, 3, 4, 5. You travel in total 5 blocks. I'm going to use the same highlighter. How many blocks did you travel sideways? On these 5 here, how many are you traveling sideways? 1, 2, 3, correct? How many are you traveling up and down? 1, 2, right? Just 2? Here you go, guys. Oh, I forgot the factorial next to 5. Please introduce that. 5 factorial is 120. This is 6 times 2 is 12. How many ways? 10 ways. It matches our counting method. Okay? That's something that you should observe. I'll leave the other one to you, and I'll just tell you there's 35 ways. You're going to practice that. Both methods. So just write down the answer. Easy peasy, this one. It's just a grid, A to B, not much to it. Okay, let's go to the next page. For our second case, I consider that there's, in my books, there are 3 cases. I'm going to do this one with you. This one I call a bottleneck. There's a bottleneck here. Determine the number of ways one could travel from point A to C. So which way are you traveling? A to C, right? What's the condition here? What is the obvious setup? Where do you have to go through to get to C? That's the bottleneck right there. So can you just go, I'm going to go to A to C, guys. Can you just say A to C? I would argue no. We will have to go from A to B and B to C. Would you agree with me on that? What does and mean in math? In this particular unit, and is multiplying, or is adding, right? And tells me I have to multiply. So guess what? How many times do you think you're going to have to use the formula? If you're using the formula, 2 times. Okay? So from A to B, how many are there in total? How many steps would you take to get from A to B in total? 1, 2, 3, 4. It's 4 factorial. Divided by, how many are we going sideways? I did sideways green, right? 2 sideways. And 2 down. Okay, I'm going to put a big set of brackets around this whole thing. I'm going to figure out what that is later. Now I'm going to go focus on B to C. How many am I going in total? 1, 2, 3, 4, 5, 6. 6 factorial. How many am I going sideways? 4, right? 4 factorial. And how many am I going up and down? 2. Put a big set of brackets around it. Question. What if there had been another bottleneck? Like you see down in this example, how many times would you have to use the formula? 1, 2, 3 times. You're going to have to do what I just did 3 times. Okay. 1 bottleneck. Let's clean this up. 4 factorial is 24. This is 2 times 2, which is 4. Times. What's 6 factorial? Do you have it on your study sheet? 720, yep. This is what? 24 times 2, 48. This is why I told you put it on your study sheet. It will save you a ton of time. 24 divided by 4, 6. 720 divided by 48. You'll be impressed by my mental math skills. Just like that. 90. There's 90 ways to get from A to C. Take a deep breath, okay? Okay, one more thing I need to tell you. Sometimes the question says you got to go from C to A. You got to go upwards. It doesn't really change anything. It doesn't change anything because you can only travel sideways and up and down. So whether you go from C to A or A to C, it's going to be 90 ways. So please don't let that throw you off, okay? You treat it the same way. Let's do the counting method. So you start here. It's going to be 1, 1, right? If you go downwards, it's going to be 1 to this intersection, 1 to that intersection. 1 and 1 is 2. 2 and 1 is 3. I hope you can see that. 1 and 2 is 3. 3 and 3 is 6. And now what? 6 to get to here. So now we continue this. There's still 6 ways to get to here. Because remember, once you get to here, it's still the same, like you're still traveling sideways. So it's 6 ways there, 6 ways there, 6 ways there. Doesn't change. So this number just gets copied along all of those intersections because you're not turning, so we're not changing it. The 6 is 6 here as well, and it's 6 there as well. Okay? Now, 6 and 6 is 12. 6 and 12 is 18. 24. You just got to use your calculator. Be very careful here. 30. You go down here again. So the important thing is to copy down the numbers along the sides, or else you'll be stuck. 6 and 12 is 18. 18 and 18 is 36. 36 and 24. That would be 60, right? Oops. 60 and 30, 90. There we go. That's what we want. We want 90. Okay? So there we go. That's how it works. Yeah. Question? Ask later? Okay, no problem. Hold on. I want you to know why this works. Guys, if you travel from A to B, what would it be if you could only go east-west? It would be east-east, south-south, right? And east, 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 so there's 4 east. South, south. If I asked you to scramble, listen carefully. If I asked you to scramble the words, the letters in this word, what would you do? If I just gave you that word, what would you normally do? What do? We count the letters. How many letters? 4. And then we divide out the duplicates, right? And then you've got a word. How many ways can we scramble the letters in this word? We count 6. We divide by the 4 e's and by the 2 souths. Okay? So we're trying to figure out how many ways can you, if you only are allowed to go east and south, how many ways can you go from A to B? Right? Anyways, that's why that works. This is the explanation. It may not mean anything to you right now, but maybe later on. Okay? And the last one. The last one. I want to do all 3 today. Tomorrow I'll probably give you an AC just to see where you're at. Okay? So you get to practice 1 of each. Let's go to 38. Highlight this one. Is there just one bottleneck? There's 2 ways to get from A to B, right? 2 bottlenecks. So let's just write out what we're gonna do here. Option 1 would be what? A to D. And then what? From D we go to B, right? So A to D, D to B. Or A to C, and then C to B. What? So, Mr. Erickson, are we going to use the formula 4 times and add it? Yes. But I'm going to stop highlighting here because it's going to get too crazy. Just think about it. From A to D, how many ways are there total? 1, 2, 3, 4, correct? You always make a rectangle. 4 factorial. How many ways can you travel sideways? How many ways can you travel up and down? You notice that 1 and 3 adds up to 4. Have you noticed that pattern? It doesn't necessarily mean you're doing it right, because if you miscount, okay? D to B, how many ways to go from D to B? 1, 2, 3, 4, correct? 4 in total, 4 blocks. And you travel sideways 3 times. You travel up and down 1 time. Do we need the 1 factorial there? No. But it's just so you see. What do we do with OR? You go plus, because it's 2 cases. Case 1, you can do case 1, case 2. So now from A to C, how many ways? 1, 2, 3, 4. There's, if you consider AC, it's a box like this. There's 4 ways to get there. And it's 2 factorial sideways, 2 factorial because of the north-south travel. Now we're going to consider from C to B, so you almost want to ignore everything else, and it's just 1, 2, 3, 4. Still 4 factorial. Divided by 2 sideways, and 2 up and down. You should not have decimals. You're in trouble if you have decimals, okay? So this is 24 divided by 6. 24, let's write it out, why not? 24 divided by 6. This is still 24 divided by 6. Plus 24 divided by 4. Just have to be careful that you don't. So this is 4 times 4 plus 6 times 6. 16 plus 36, right? And that will give us 52, yeah. Before we go, let's do the counting real quick. So it's 1, 1, 1, 1, 1, right? So you go 1 on the edges, and then you just add 1 and 2 is 2, 2 and 1 is 3, 1 and 2 is 3, 3 and 3 is 6. Watch this. Not yet, I'll finish this. 1 and 3 is 4, 4 and 6 is 10. Okay, question. This 6 here continues on. This is 6, and that is 6. If this is 4, what's this number at this corner here? This 4 continues, and then just keep filling it in. 16, 22, 6 and, sorry, this is 10, right? 14, 30, and 52. Mission accomplished. Okay, let me give you the answers. I mean, I have it all scanned out, but let me give you the answer to the one down here. You're supposed to get 275 ways. 275, and the one before is 4,200. This one before. Yes, I know. The more you options you have, the more pathways there are. I would say you don't have to do counting, but I would say it's good practice to learn how to count. In fact, no, I take it back. You count as well. There's one case where you need to know how to do the counting method. So, all the way to 39. I'm going to paste everything to 39.